Alright, on lesson 6.1 we are doing something called the law of sines, and then 6.2 will be the law of cosines. What you need to know first is that we are working with oblique triangles, which are triangles without right angles. And the standard notation is to write the angles with capital letters, and then the sides opposite those angles, that's what those little arrows are for, are written with lowercase letters. Alright, and then there's a big list of things to solve an oblique triangle. That means to find all of its side lengths and all of its angle measures. And then you need to know at least those criteria that are listed, the 1, 2, 3, or 4. We are only dealing with cases 1 and 2, so 2 angles in any side, and then 2 sides, and an angle opposite one of those sides. So that is going to be the law of sines. 3 and 4 will use the law of cosines. The law of sines is circled. It can also be written flipped, the part that says or, but it's really easy. So A over sine of A, B over sine B, C over sine C. So for the first triangle, let's see what we know. We know angle B and angle C, so let's go ahead and figure out angle A. Since the three angles of a triangle add up to 180 degrees, I'm just going to subtract those two to find the third angle. Right, so that is 49 degrees. Now we know all of the angle measures, and we know one side length, which is B. So I want to go ahead and find side A. So A over sine of A equals B over sine of B. Make sure you fill in that formula correctly, and then we're going to cross multiply. So A times sine of 28.7 degrees equals 27.4 times the sine of 49 degrees. And then we'll divide the left side by sine of 28.7 so that we can get A by itself, because we're looking for that side length. Make sure your calculator is in degrees, because we're using degrees instead of radians. And then plug that in. Make sure you use parentheses where necessary. Right, and then you end up with A equals 43.1 feet. So we have one more side length to find. Since this is not a right triangle, we can't just do A squared plus B squared equals C squared. We're going to use C over sine of C equals, I'm just going to go ahead and use B over sine B again, even though now we know little a, so we could use either one. You should end up with the same answer either way. Alright, so cross multiply. I just got that out of the way because I was writing a little too big. And then I end up writing very crooked right here. I apologize. But it's 27.4 times the sine of 102.3. And then divide by sine of 28.7 again. And you will end up with your side length for C. So C is 55.7 feet. Alright, and now we're done. We have all the angles, all the side lengths. So for number 2, I went ahead and drew this triangle for you. It doesn't really matter what way you set it up. Like, it could go A on the top, and then B on the right corner, and C on the left. It doesn't matter as long as your angle and the appropriate side length are opposite each other. Such as, so angle A is 30 and then side A is 22, so those should be across from each other. But it doesn't matter which way you spin it, you know? So setting this up, 32 over sine of 30 is A over sine A equals B over sine B. And I already found angle C while I was chit-chatting by subtracting A and B from 180. Alright, cross multiply and divide. You end up with side B equaling 45.3. Alright, now we need to find side C, and then we're done. So I went ahead and used A over sine A again, and then C over sine of C, which is 105 degrees, which we found again by subtracting A and B from 180 degrees. Cross multiply, so 32 sine of 105 equals C times sine 30. Divide by sine 30 on both sides. Plug all that into your calculator and you will end up with the side C. And side C equals 61.8 feet if you worry about labels or units. Alright, for number 3, we have new measurements that we're using. So I'm setting up my triangle ABC and writing the side lengths across from the appropriate angles. And I'm going to fill in the angle measures that I was given and the side lengths that I was given. So this time we were given 2 side lengths and an angle, so I can't just subtract from 180 because I don't know 2 of the angles this time. So I am setting up 12 over sine 31, A over sine A, equals B over sine B, and B is 5. So this one's going to turn out a little different when we solve, but that's alright. So cross multiply, divide by 12. We have sine B equals 5 sine of 31 degrees over 12. Now how do we get B by itself? Well, when we're solving, we do the inverse of everything. If it's being multiplied, we need to divide. If it's being added, we subtract. But this time, since we're taking the sign, we need to take the inverse sign to get rid of that sign. So take sine inverse of both sides, and you end up with something that looks pretty messy. But that will give us angle B equals the inverse sine of 5 sine 31 degrees over 12. When you plug that into your calculator, you should end up with 12.4 degrees. Now that we know 2 angles, we can go ahead and find the third by subtracting the 2 that we know from 180 degrees. And that is 136.6 degrees for angle C. So now we can find the side length of C. Again, starting with 12 over 31, just because I think it's easier than switching to a different ratio, equals C over sine of 136.6. This one is like examples 1 and 2. We don't have to take the inverse sign because we are looking for a side length, not an angle. Cross multiply, divide, plug it all into your calculator, and you should end up with your measure for the side length of C, which is 16. Perfect, done with that. Alright, I finally switched my board over so that it would fit the screen. This ambiguous case is just showing you that it doesn't always work out to make triangles with the side lengths and angles you're given. Or in the fourth case, it turns out that you could have 2 different triangles when A is between the length of the height and side B. So it'll tell you when it's just like this first one is just one case. You don't have to worry about not finding a triangle or, finding 2 triangles. Instead, it'll tell you when you're dealing with which one. So go ahead and fill it in as usual. I am first going to find angle B. So I already know I'll have to use sine inverse at the end to get b by itself. Go ahead and cross multiply and divide, get sine b by itself. Alright, so we end up with sine b equals 12 sine of 42 degrees over 22. And then take the inverse of both sides to get b by itself. Plug that big thing into your calculator, and you end up with angle B equals 21.4 degrees. Now we can find angle C since we know two of the other ones. Subtract from 180, and that gives us 116.6 degrees. So the last thing we need to find is the side length C. So I'm setting up my ratio A over sine A equals C over sine C. You know the drill. Cross multiply and divide to find C. Alright, plug that into your calculator. And you end up with C equals 29.4 feet, inches, I don't know, 29.4. Alright, this one says, show that there is no triangle for which one side length is 15, another is 25, and the angle across from the 15 is 85 degrees. Alright, this really does not make sense because if you remember from geometry, well, hold on. Before, we're going to go ahead and set it up and try to solve it like we would a regular triangle, even though we know something is going to go wrong. So what goes wrong for us here is you'll end up with an error in your calculator when you are solving for the angle of B, and that will tell you that there is no triangle that matches this description. But as I was saying, if you remember from geometry, the biggest angles have the biggest side lengths opposite them, and an angle of 85 degrees has a side length of 15, and angle B, whatever it is, has a side length of 25. So it's got to be bigger than 85 degrees. And even if it's just like, I don't know, 90 degrees, that means angle C could only be 5 degrees, and it doesn't work out. Because the angle actually ends up being much bigger, or has to be much bigger to have that much bigger of a side length. So you'll get an error in your calculator. Or this one is finding two triangles for which A is 12, B is 31, and angle A is 20.5 degrees. Alright, again, I'm going to go ahead and set up to solve for angle B. So I start off with A over sine A, 12 over sine of 20.5 degrees, equals 31 over sine of B. Now this time just cross multiply, solve like normal. In example 1, if you want to pause and go back to it, or maybe go back to it in a minute. In example 1, we ended up with finding angle B to be 21.4 degrees. If we would have subtracted that from 180, we would not have had room for that large of an angle in our triangle. But because A is so small and B is relatively small, I could also have an angle that is the reference angle. This is very confusing to explain without being in person and having like a little model or something. But I think I'll come up with a better way to explain it later. Maybe I'll send you a link to a video that explains it well. But anyways, angle B could also be 180 minus 64.8, which gives you like 116.2 degrees, and then you still have enough left over to have an angle C. So as long as it fits in the triangle, you could have two different triangles. But for now, you can just copy down this problem and we will figure out a better way, or I will figure out a better way to explain this. So, skip that one. Don't worry too much about it. It's confusing. Let's go on to areas. Those are much easier to solve for. Alright, each triangle has an area, if you remember from geometry, of 1/2 times base times height. Well, right now, we know that our height, if we went through a big trig little proof, the height is equal to B times the sine of A. So now, instead of our area being 1/2 base times height, we've got 1/2 of the two side lengths we know times the sine of the included angle. And really, you don't need to know the explanation of why, just know that this is the formula. So it's the bold 1/2 of BC sine A, or 1/2 of AB sine C, or 1/2 of AC sine B. So for number 1, there's the triangle all set up, and it looks like we have sides A and C, and we have angle B, so I'm going to use that third formula. 1/2 times 90 times 52 times the sine of 102 degrees gives you an area of 2288.9 square meters. Write this next one. I end up setting it up basically the same as number 1, and I can just fill in that formula with my new numbers. So the area equals, again, AC times sine B. So 1/2, I forgot the 1/2 before when I was talking. 1/2 times 18 times 24 times the sine of 80 degrees. This gives us 212.7 yards squared. Don't worry about the ambiguous case, I am so sorry.